This video is intended to provide some trigonometry background from my video series on visualizing the 6 trigonometric functions. I'm Dennis Davis. If you found this video some other way, welcome. I hope you find it interesting and informative. If you haven't taken trigonometry yet, this could provide a big boost to your preparation, but it's not a comprehensive trigonometry course. I'll cover 5 important trigonometry concepts, and the first is the longest, so don't worry, the pace will pick up. The word trigonometry, which I'll often abbreviate as trig, means triangle measurement, but it's really about angles. We use triangles, quite a bit actually, to define trigonometry concepts, but trig starts and ends with angles. So we will start with an angle, any angle out in space. Angles are usually, but not always, denoted by a Greek letter, and the Greek letter theta is by convention a common choice. So we'll label our angle theta, which looks like the letter O with a horizontal line through the middle. Now we're going to create an imaginary triangle using this angle, and we're going to use that imaginary triangle to describe the trigonometric functions of the angle theta. I'll show how this is done using a memory aid I used in high school. The sillier it is, the easier it will be to remember, okay? Fair warning. Imagine a paper cutter and put a blue horizontal guide on it. We'll use colors for memory aids later, especially in the next video series, so please just trust me, the horizontal guide is blue. We take the angle theta and we line up one of its arms to the blue guide, putting the angle's arms out over the right edge. Then we imagine cutting a red line with the paper cutter. This creates a triangle using the blue side, the red side, and the other arm of the angle, the one we didn't line up with the blue guide. I'll color it yellow. It's a right triangle, of course, because the blue side and the red side are perpendicular. The square symbol in the corner means the angle is a right angle. Each side of the triangle has a special name from the perspective of angle theta. The side that's opposite, that is, the red one across the triangle from theta, is called the opposite side, usually abbreviated OPP. The longest side, which will always be the side across from the right angle, is called the hypotenuse, abbreviated HYP. The blue side that we lined up with the blue guide is called the adjacent side, ADJ, because it's right next to theta. The 6 trig functions are simply the various ratios between the lengths of these 3 sides. There are only 6 possible ratios between pairs, and here they are. Opposite divided by the other 2, adjacent divided by the other 2, and hypotenuse divided by the other 2. These 6 ratios correspond to the 6 trigonometric functions, and here are their names: sine, cosine, tangent, cotangent, secant, cosecant. The trig functions all have 3-letter abbreviations. Abbreviations for 5 of them, the first 5 in the order I've listed them, are just the first 3 letters of the spelled-out function name. But the abbreviation for cosecant can't be COS because that's already taken by cosine. So by convention, the abbreviation for cosecant is CSC. We'll start with these first 3, sine, cosine, and tangent. A popular mnemonic to remember these is SOHCAHTOA, SOHCAHTOA. Each 3-letter component of SOHCAHTOA is intended to denote a trig function and its ratio. So, SOH, sine is opposite over hypotenuse, SOH. CAH, cosine is adjacent over hypotenuse. TOA, TOA, tangent is opposite over adjacent. Let's do a quick example. I consider an angle theta, put it on our paper cutter, measure, and get the lengths shown in the triangle. The hypotenuse is 7.4 meters. I guess I imagined a very large paper cutter. And the adjacent and opposite sides are 6.1 and 4.2 meters, respectively. Let's use SOHCAHTOA to find the sine, cosine, and tangent of angle theta. So, SOH, sine equals opposite over hypotenuse, 4.2 meters divided by 7.4 meters is 0.568. CAH, C-A-H, cosine equals adjacent over hypotenuse, 6.1 meters divided by 7.4 meters. TOA, T-O-A, tangent equals opposite over adjacent, 4.2 meters divided by 6.1 meters. Please chant SOHCAHTOA to yourself and know the corresponding formulas for sine, cosine, and tangent. Here, you might consider making 6 flashcards. You should know these frontwards and backwards, and fortunately, SOHCAHTOA makes it easy. The last 3 trig functions are just reciprocals of the first 3. Remember, it's easy to take the reciprocal of a fraction. The top and bottom just switch places. So the reciprocal of a over b is b over a. The cosecant is 1 over sine, so hypotenuse over opposite. The secant is 1 over cosine, so hypotenuse over adjacent. The cotangent is 1 over tangent, so adjacent over opposite. You don't need to memorize something if you can figure it out quickly, and these last 3 trig functions are good examples. Don't memorize cosecant, secant, or cotangent. I haven't. Just memorize sine, cosine, and tangent, which, by the way, SOHCAHTOA makes so easy it hardly counts as memorization. We just have to know which of these other trig functions, cotangent, secant, and cosecant, is paired with each of our first 3 SOHCAHTOA functions, sine, cosine, and tangent. And here's how to do that. Each reciprocal pair includes exactly one function whose name starts with co, C-O. We start by pairing up tangent and cotangent because their names are similar. SOHCAHTOA reminds us that tangent is opposite over adjacent, so cotangent is flipped, adjacent over opposite. But sine and cosine don't sound like secant or cosecant. Well, since each pair has exactly one co, sine can't be the reciprocal of secant, so it must go with cosecant. And cosine must be the reciprocal of secant. There's one co per reciprocal pair. Here are 6 more flashcards. These will probably take a few extra seconds to answer, but that's better than memorizing. Whatever you can memorize, you can easily forget, but what you know how to figure out, that you can do forever. Let me make 4 important points about these 6 functions. First, the trig functions are properties of angles, not triangles. An angle out in space, or an angle drawn in a homework or test problem, has a sine and cosine even if there isn't a triangle drawn. We just imagine the triangle, using a paper cutter if you like, to help visualize the meaning of the ratios. Triangles don't have sines, cosines, or tangents. Their angles do. Second, the trig functions are unitless. Since they're the ratio between 2 lengths, the unit of measure cancels out. So the sine of theta would never be 0.568 meters or 0.568 feet, but merely 0.568. Thirdly, trig functions are mathematical functions, but unlike traditional functions that include their argument in parentheses, trig functions are usually written without any parenthesis. When reading an equation out loud, we say sine theta or cosine gamma. We don't say of like we would for other functions like f of x. There's a common verbal and written shorthand regarding trig functions, and you should be familiar with it. Finally, when we square trig functions, which we'll do a lot when we use the Pythagorean theorem, we write the exponent 2 between the function abbreviation and the angle variable. This would be read out loud as sine squared theta, not sine of theta squared. It's a little different, but you'll get used to it. Well, that was part 1 of this introductory video, and it was the longest. Mercifully, part 2 will be the shortest. We imagine a plane with perpendicular x and y axes. By convention, the x-axis is usually drawn horizontally with a vertical y-axis. And by convention, the x-axis has a positive direction to the right and a negative direction to the left. Similarly, the y-axis has a positive direction up and a negative direction down. The point where the x and y axes intersect is called the origin. Any of the infinitely many points on the plane can be identified by two numbers. The x-coordinate, which represents its distance, positive or negative, along the x-axis, and the y-coordinate, which represents its distance, positive or negative, along the y-axis. So every point in a plane is identified by an ordered pair of xy coordinates. The axes divide the plane into 4 quadrants, labeled with Roman numerals like this. All of the points in quadrant 1 have a positive x-coordinate and a positive y-coordinate. In quadrant 2, the x-coordinate is negative, but the y-coordinate is still positive. For points in quadrant 3, both x and y coordinates are negative. And in quadrant 4, the x-coordinate is positive and the y-coordinate is negative. You shouldn't need to memorize these. Just picture this Cartesian coordinate system in your head and decide which direction from the origin to go to get to each quadrant. Horizontal first, right or left, vertical second, up or down. Here are 8 more flashcards. This might seem meaningless or trivial, but quadrants are a handy way to evaluate trig functions, and they'll be important later, especially in the next video series. Expressing and measuring angles in degrees is probably familiar to most people. Here's a circle showing some common or interesting angles. Each label corresponds to the size of the angle at the origin from the positive x-axis swept around counterclockwise to the labeled point. In this example, the arm passes through the 30-degree point on the circle, which means the arm makes a 30-degree angle with the x-axis, as shown.